Hello everyone. Today let us learn about how to balance a redox reaction by ion-electron method. Okay. So generally, what is an oxidation or reduction reaction? So generally oxidation is loss of electron and reduction is gain of electron. When these both occur simultaneously, it is called a redox reaction. Okay. Today let us learn how to balance a redox reaction by ion-electron method. Okay. So here is the equation, our ionic equation Cr2O7 2 minus plus I minus forming Cr3 plus and I2. So let us first go through how to balance the redox reaction. The first and foremost you have to do is, first you have to write the oxidation number of each atom. Okay. Here chromium Cr2O7 2 minus, general oxidation state of oxygen is -2 and chromium, let us take it as X. There are 2 chromium, so 2x minus 7 2s are 14 is equal to, the overall charge is -2. So 2x is equal to 12 and x is equal to +6. The oxidation state of chromium here is +6. Okay. While balancing the redox reaction, generally the first step is to write all the oxidation number of each atom. Here oxygen is -2 and here iodine, it is having the -1 charge, so oxidation state is -1, and here chromium is having 3 plus, that is the oxidation state is 3 plus, and I2 is it is in the elemental state. If it is in the elemental state, it is 0. Okay. Now we wrote all the oxidation state of each atom in the ionic equation. The second step is to find out which is undergoing oxidation and which is undergoing reduction. Let us see here, chromium from +6 to +3. +6 to +3, there is a decrease in the oxidation number. Decrease in the oxidation number indicates reduction. Okay. Here iodine, you can see -1 to 0. -1 to 0 is, there is an increase in the oxidation state, so it indicates oxidation. Okay. Now let us write the oxidation half cycle and reduction half cycle separately and balance it. Okay. First let us write the reduction half cycle, Cr2O7, this is your reduction half cycle. Cr2O7 2 minus forming Cr3 plus. Okay, here you can see Cr2O7 2 minus forming Cr3 plus indicates the reduction. So let us take it as reduction half cycle. You can see here, after writing separately the reduction half cycle, let us balance atoms other than oxygen and hydrogen. Here you can see, other than oxygen you have chromium. You have 2 chromiums here on the left hand side, on the right hand side you have only 1, so let us put 2 here. Now chromium is balanced, we don't have any other atoms except chromium. Okay. Next let us balance oxygen. Now we should balance oxygen by adding number of required water molecules towards the deficient side. See, you can see here there are 7 oxygen and there is no oxygen here, so let us add 7 water molecules to the side deficient in oxygen. Now oxygen is balanced, but there is hydrogen here, which is 7 to the 14 hydrogens. So to balance hydrogen atoms, we should add number of H plus ions required on the deficient side. Here 14 hydrogens, we should add 14 H plus on the deficient side. Okay. Now everything is balanced. Okay. Now let us, the last step is to balance the charge. We should balance the charge here. You can see here 14 H plus, there are 14 positive charges and 2 minus, that is 2 negative charges. Overall on the left hand side we have 12 positive charges. On the right hand side you can see, okay, you have 6 positive charges. Okay. So to balance this, we should add 6 electrons on the left hand side. If we add 6 electrons on the left hand side, so the overall charge will be balanced. Here +6 and here also +6. So on the left hand side, let us add, okay, 6 electrons. 6 electrons. Understood? This is about the reduction half cycle. So now let us balance the oxidation off cycle. So what is the oxidation off cycle? You can see here I minus forming I2. I minus forming I2. First is to balance other atoms, okay, except oxygen and hydrogen. Here you can see iodine. It is having two iodines on the right hand side. Here you have only one. So let us balance iodine by putting 2 on the left hand side. Now we don't have any oxygen and hydrogen to balance. So now it is balanced. We should balance the charge. Okay. Here you have two negative charges. But here you have no charge. So to balance this, we should add 2 electrons on the left hand side. If we add 2 electrons on the left hand side, it will become, I mean to say, you should add 2 electrons on the deficient side. Okay. If we add 2 electrons here, so it will be balanced. Okay. So this is your oxidation half cycle. This is reduction half cycle, oxidation half cycle. Now the last step is to equalize the electrons on both the sides. Let us take both the equations here. Cr2O7 2 minus plus 14H plus 6 electrons forming 2Cr3 plus 7H2O. Let us see the oxidation half cycle. 2I minus forming I2 plus 2 electrons. Okay. Let us add the equations. We should first equalize the electrons. Here you have 6 electrons and here you have only 2 electrons. Let us multiply this equation by 3 so that we get 6 electrons. Okay. 6 electrons will get. So these electrons gets cancelled here. Now let us add the equation. Here you have Cr2O7 2 minus plus 14H plus 2. See here 3 2s are 6. I minus forming. Let us write the right hand side now. Products 2Cr3 plus 7H2O plus, you can see here 3I. Now it is balanced. You can see here this reaction is balanced. It is in the acidic medium. You can see here 14H plus ions indicates that the reaction is in the acidic medium. Okay. Hope you understood. See here in the first step we should write the oxidation number of each atom. In the second, next we should identify which is undergoing oxidation and reduction. Then we should separately write down the reduction half cycle and balance other than oxygen and hydrogen in the first step. Next we should balance oxygen by adding required number of water molecules on the deficient side. We should balance hydrogen by adding number of H plus ions in the required side, okay, in the deficient side. And similarly oxidation half cycle also is balanced. After balancing we should add the equations by equalizing the electrons, okay. And finally we will get a balanced equation. This is how we balance a redox reaction by ion-electron method. Okay. Hope you understood. Thank you.